So this is AIO REPL, which Jim wrote and merged recently. Asynchronous IO REPL. So it's kind of like having a task, a task which is the REPL. That's what it is. It's kind of like having a shell. When you log into a Linux machine, you can have a shell, and you could have lots of shells. So you could actually have lots of AIO REPLs at once. So to run it, so this is just on the Unix port. So if I import AIO REPL, and then I do import async IO, or async IO, let's call it async IO, and I go async IO.run. So I want to start AIO REPL's task. Okay, so now we're in the AIO REPL, and it has this minus arrow. So this is like a normal REPL. You can do things, not exactly the same, but close. And it's basically you enter text and it evaluates it and prints the answer out. So print, and it will print it out. And then, but you can do things like await async IO.sleep, and that's actually a proper sleep, where you can't normally do that at the REPL. And then I have this prepared demo here on the side. It's just a function. It's just an async IO task that will, in an infinite loop, print blink, and then sleep for the given time. So we can import that and do async IO.create that task, blink.blink, and we'll say every 2000 milliseconds. Every 2 seconds we want it to blink. So it's every 2 seconds it's printing blink, but I still have this AIO REPL available, so I can still do things at the REPL. And I can create another one. So, and I'll give it, so T for is, we'll create another one. Okay, so now there's 2 blinking tasks going on in the background. You can see it's going faster than every 2 seconds because there's 2 of them. And I can still do things. And at the prompt also await. Of course, it's hard to type because things keep, oops, await async IO.sleep 5 seconds. So I can also sleep while the other things are happening, and then the prompt will come back in 5. Yeah, there we go. Obviously the blinking would be an LED blinking, and then I could continue typing. But you can imagine you would have a device which was running an async IO program, and you can log into the device like this by having a REPL that you can access, and you could inspect state and change things and so on, and maybe even get a listing of all your tasks that are running. We haven't implemented that, but that'd be cool. Because for example, this T was the second blinker that I made. I can do T.done, just query if it's done, false, and I can do T.cancel to cancel it. So now there's only 1 blinker left. So T.done, true, T is cancelled. So it's really like a mini operating system in that sense, that you can create processes and kill them, or create tasks and kill them. So
it's actually really
useful. That's state variable to false, it will stop. So if I go blink state equals 0. Oh, what happened? My internet's unstable, it says. So blink state equals 0, and then it task, because it will that state to go to 0. So yeah, I think this is very useful if you're developing a applications, asynchronous. Jim said it supported history, but it's not working here, and it doesn't support tab completion. But those are things we can improve. And I think, yeah, moving in the direction of everything becoming async IO based is, I think, something that's happening. And like with AIO BLE, AIO Bluetooth, and more things, I think will go this way, and you'll be able to make even better MicroPython applications. But
I'm going to look into this tomorrow. This is amazing.
Yeah, so it's there, it's merged, and it's got a little readme. If I exit, I think you use Control D to exit, but it has there's a few bugs. This is very But it has a nice a little readme which you can read to understand in this demogram here. And yeah, list of limitations. So that was the demo Jim was, I think, going to give, and hopefully I did it a bit of justice.
Thank you, especially because it was so on the spot. That was great. Because you used this recently for work.
Yes, I've used.
Sorry.
Hi. So yeah, I work. We do a lot with the WB55 STM chip with Bluetooth. So naturally using AOI BLE, which Jim Sarah also had wrote an enormous part to play in. But it's been really powerful to be able to have like the real production firmware flashed onto a device and it actively running. But in this, our startup loop sort of started the AIOREPL, so it's there in the background, and the device is just running as per normal, talking on Bluetooth, but at any time can just plug in the UART to get to the REPL, and you don't have to control C to get back to the regular REPL anymore and kill your application. The async REPL is just there ready to be interacted with. So can query what's going on, change state, change the way the device is running, or switch it into a different mode manually.
It's an amazing debugging tool. Yeah.
Yeah, without actually interrupting the program at all. And sort of just to really speed up a lot of that sort of live building up of an application. And then disconnect from the REPL and the device is still running. So
and I think it's worth emphasizing that the REPL doesn't have to be USB serial or a UART. It's anything that can receive and data. So it could be a Bluetooth asynchronous, it could be a Wi-Fi asynchronous, or it could be a LoRa one. Well, maybe LoRa, but anything that can send and receive data, we could make an asynchronous REPL on.